Next, acceleration due to gravity. Okay, so we have no doubt seen gravity work in our life, isn't it? After all, it is the force that is helping us to keep our feet on the ground. That is gravitational force, isn't it? So if we throw a ball in the upward direction in the air, then it will come down on its own, isn't it? You know, because of gravitational force. So when the ball is going in upward direction, its speed will be less as compared to when it comes down, isn't it? This is because of the acceleration which is produced due to the force of gravity. So it is called as the acceleration due to gravity on the earth. Okay, so this is the acceleration which is produced due to the force of the gravity. So it is called as acceleration due to gravity on the earth. Okay, so it is represented as G. Its unit meter second power minus 2. So mean value of the acceleration due to gravity is taken as 9.8 meters second power minus 2 on the surface of the earth. So this means that the velocity of your body during the downward free fall motion varies by 9.8 meters second power minus 1 for every 1 second. Okay. However, the value of G is not the same at all points on the surface of the earth. It will be discussed later. Okay. Next, the relation between G and G. So you know G, acceleration due to gravity. This is universal gravitational constant, isn't it? So when your body is at rest on the surface of the earth, it is acted upon by the gravitational force, you know, so of the earth. So let us compute the magnitude of this force in two ways. Okay, so consider m is the mass of the earth and small m is the mass of the object. Okay, so capital R is the radius of the earth and small r is the radius of the object. When compared to earth radius, the object radius is very small, so it can be neglected. Okay, so what is the universal law of gravitation? Every object in the universe attracts another object with a force. Listen, every object in the universe attracts another object with a force. This force is directly proportional to product of the masses, so m into m, and inversely proportional to the square of the distance. Here distance is r, square of the distance r square. Okay, so f is equal to g m by r square. G is the gravitational constant, universal gravitational constant. Okay, so according to Newton's second law, you know, F force is equal to mass into acceleration. Here acceleration due to gravity. So we write the equation F is equal to mg. So listen, equation 1 and 2. From equation 1 and 2, substitute the value of F, that is mg is equal to g m by r square. Cut the term m and m. Here we get the answer, acceleration due to gravity g is equal to g m by r square. Okay, so this is the relation between g and g. So the radius of the earth is given in your book, that is r is equal to 6378 kilometer, approximately 6400 kilometer. Okay, this is the relation between g and g. Okay, next, mass of the earth. Okay, from this equation already you know g is equal to g m by r squared, isn't it? So from this equation we can obtain the value of m. So m is equal to g r square by g. Okay, so already you know the values of g, 9.8, or radius of the earth, that is 6378, and g 6.674 into 10 to the power minus 11. Okay, so substitute the values and you can calculate the mass of the earth as m is equal to 5.972 into 10 power 24 kilogram. Okay student, next one, how the acceleration of gravity varies from place to place. See, variation of acceleration due to gravity. So that means g is equal to, you know, gm by r square. From this equation, you know, g is inversely proportional to r square. R means radius of the earth, isn't it? So from this equation, you know, since g depends on the geometric radius of the earth, its value changes from one place to another on the surface of the earth. Okay, so the value of G is minimum at the equatorial region because here radius of the earth is maximum. Radius of the earth is maximum means value of G is minimum. Okay, the value of G is maximum in the polar region because radius of the earth is minimum in the polar region. Okay, yeah. So when you move to a higher altitude from the surface of the earth, the value of G reduces. In the same way, when you move deep below the surface of the earth, the value of G reduces. So the value of G is 0 at the center of the earth. Okay, so it will be deeply discussed in the higher classes. Okay, student. Next one, already you know this chapter, mass and weight, isn't it? In the previous class itself you know the terms. Once again recall the chapter. Mass of your body is defined as the quantity of matter contained in the body. Okay, its SI unit kilogram. Mass of your body is always constant everywhere in the universe. Okay, next one, weight. So what is weight? Weight of your body is defined as the gravitational force exerted on it due to the earth gravity alone. Okay, so the SI unit of weight is Newton. SI unit of weight is Newton. So weight increases or decreases with higher or lower gravity. Okay, it varies from place to place. So what is the formula for weight? Weight is equal to gravitational force. That means F is equal to mass into acceleration due to gravity. Okay, so acceleration due to gravity for earth at sea level, you know, G is equal to 9.8 meters second power minus 2. So acceleration due to gravity on the surface of the moon is 1.625 meters second power minus 2. Okay, yeah. So it can be explained in simple example. Listen, if a person whose mass is 60 kg stands on the surface of the earth, so his weight, how will you find the weight? So W is equal to mg. M is 60 kg, so 60. G, that is acceleration due to gravity, that value is 9.8. So multiply m into g, we get the answer 588 Newton. Okay. Next one, if the same person goes to the surface of the moon, he would weigh only 97.5. How? W is equal to mg. So m is 60. Acceleration due to gravity on the surface of the moon 1.625. So multiply, we get the answer 97.5 Newton. But his mass remains the same on both the earth and the moon. Okay, this is the difference between mass and weight. Okay, so today's over part. That's all. Thank you, students.